All right, so we're going to look at vertically stretching and shrinking graphs as well as horizontal. So let's look at the first one, vertically stretching and shrinking. It says if or when, and let's go from the examples here. Now this is our parent graph. Our f of x is equal to the absolute value of x. What happens when there is a number in front of the graph? Okay, so that's what we're going to be looking at. So don't forget that our original graph, here's the table. And we have, what is that? 21012. Okay, so this is our original graph. These are the points. Now, um, notice that we have a graph of h of x is equal to 1/2 times the absolute value of x, and we have p of x is equal to 2 times the absolute value of x. So what we want to look at here is noted that whenever our c is greater than 1, okay, the graph is going to vertically stretch, and we do so by multiplying the y coordinate by that number. Okay, so when c, our constant number, our positive, our real number, if it's greater than 1, is going to vertically stretch. And notice that the numbers are in front of the absolute value. That's going to be important. Now, when the number or our c, our real number, is between 0 and 1, it's going to shrink. And still, that's by multiplying the y coordinate in the table by that number. Okay, so looking at h of x is equal to 1/2 times h of x. Okay, well, the 1/2 is between 0 and 1. So this tells me, or tells um, us, here's the equation, h of x is equal to 1/2 times the absolute value of x. This graph is going to shrink vertically. Now, how do we go about finding those points? You're going to multiply the 1/2 by the y coordinates. Okay, so here's our table, our xy table. So our focus is going to be on the y coordinates, changing that. So our x coordinates are not going to change. So we're going to multiply 1/2 to 2. So half of 2 would give us 1. Okay. Then we have here, um, we're multiplying 1/2 by 1. That's going to give us negative 1/2. We have 1/2 times 0 is 0. 1/2 times 1, we have 1/2 again. And then 1/2 times 2, that would give us 1. So if you're not seeing that, I'm pointing to the y coordinate of our original graph. You're saying 2 times the 1/2, that constant number, this is where we're getting the 1 from. Okay, so when I say that it shrinks vertically, think of when vertically we're moving up and down. Okay, our y coordinates are getting smaller. So We have negative 2, 1. We have 0, 0. We have negative 1 and 1 half. We have 1 and 1 half. And then we have 2 and 1. So, so when it shrinks vertically, our y coordinates are getting smaller. Okay. Now, we have the p of x is equal to 2 times the absolute value of x. So when our number that's in front of the absolute value sign, when it's greater than 1, it will stretch vertically. Still keep in mind that our values of x for our x column is not going to change. What's going to happen, we're going to, here again, multiply, okay, each of the y coordinates by whatever we're calling c. Our c here is 2. So go back to the original graph, and then we're going to multiply the y coordinate, each y coordinate by 2. So 2 times 2 here is 4. The second point, 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. And 2 times 2 is 4. So if you notice that when it says stretches vertically, that our y coordinates from our original graph becomes larger. So when we plot these, we have negative 2, 4. We have negative 1, 2. 0, 0. We have 1, 2. And we have 2, 4. So it stretches vertically. Okay. Now that was vertical stretching and shrinking. Okay. Now let's look at horizontal stretching and shrinking. So using the same absolute value equation, but I want you to look at what it's asking us to graph here. But look at our 1 half and our 2, where it's positioned. It's positioned between the absolute value. And whenever you have a number, be it uh, greater than 1 or between 0 and 1, when it's in the grouping symbol, it is going to stretch or shrink horizontally. Okay, so it says if our number is greater than 1, it's going to shrink horizontally. And how do we find those points? Well, this time we're going to divide, whereas before we multiply the y coordinates, this time we're going to divide the x coordinate by that number. And if our number is between 0 and 1, there will be a horizontal stretch where we're going to divide each of the x coordinates by our c. Okay, so don't forget our original graph, and then we will plot. But our original graph, we had, this was our f of x is equal to the absolute value of x. So these were our points. Okay, now we have h of x is equal to 1 half, the absolute value 1 half times x. Okay, so this time the number is inside the grouping symbol. Okay, so and it's between, this 1/2 is between 0 and 1, so therefore it will be a horizontal stretch. The graph would stretch horizontally by 1/2. And what we will have to do is create a table, and we would divide each x coordinate by 1/2. Okay, so here's our XY table. Our focus is going to be on the x coordinate. Therefore, what this is saying here, we are not changing the y coordinate. So we want to take half of, so let's look at the x coordinates from our original graph. So you're saying to find the new set of points for x, we're taking -2 and dividing that by 1/2. And -2 divided by 1/2 changes to -2 times 2 over 1. That becomes -4. -1 divided by 1/2. You're saying -1 times 2 over 1. That becomes -1. Excuse me, not -1, but -2. 0 is going to be 0. Um, we have 1 divided by 1/2. That in turns become 1 times 2 over 1. That is 2. And then we have 2 divided by 1/2. That becomes 2 times 2 over 1. That is 4. Okay. So this would be our, I'm going to put our new coordinates in green here. Okay. Now, if you go back to our original graph and plot those points, do you notice that our horizontal stretch is the same as the vertical shrink? Same points. If you plot these points on that line, okay, that we found, is what we have in green. They match. Okay. So we can say that the horizontal stretch is the same as the vertical shrink. It's not as far as if you found the ordered pairs. Okay. Now let's look at the next one we have here. When P of X is equal to the absolute value of 2. Let's get another sheet of paper here. Let's look at that one. Absolute value of 2x. The 2 is inside the parenthesis. So when it's inside the parenthesis, then it's going to, and it's great, and 2 is greater than 1, it's going to shrink horizontally, or a horizontal shrink. Okay. And just as what we have here, where it says if it's greater than 1, it will shrink. We're going to divide each x coordinate by 2. Okay. So we're going to divide each x coordinate by 2. So Here's our original graph again of the table. Negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. And we're going to take this 2. Here's our table, our XY table. What's not going to change will be the Y coordinates. Okay, so we're going to divide each X coordinate by 2. So you're saying negative 2 divided by 2. That's negative 1. You're saying when X is negative 1 divided by 2, we're saying 0.5, 1 half. 0, when it's 1, and it actually is going to be negative 0.5. Let me go back to that. When it's 1, we have here positive 1. That would give us positive 0.5. And we have 2 divided by 2. We can write it as long division or as a fraction. We have 1. Okay? So if you notice that if we go back and plot these points into this grid here, you'll notice that we will be plotting points on this blue, where you see the blue absolute value. So if you notice that our horizontal shrinking is similar to the vertical stretch. Okay, same points that we're plotting, but I just want you to make a note that our horizontal, let's find another pen here, a marker, our horizontal shrinking is the same as the vertical stretching. So here's our graph, our graphs again for this example.